Hey, friend. You know, coding can sometimes feel like solving puzzles, and Python is like this beautiful set of puzzles that I want to share with you today. Let's talk about something cool today, a function to check if a number or string, say our phone number or friendly name, is a palindrome. Let's dive in. Picture this, you are scrolling through an endless list of numbers or words. Sud 0n, right? Now let's add a filter to only pick the cool, symmetrical creations aka palindromes. Now, before you ask, no, this is not your high school play but real-life applications that could help you find patterns in data that look the same front and back. Python is an incredibly powerful tool for tasks like this, and we're about to explore how. Alright, our first step, simple and fun. Python has a neat syntax and built-in functions that make it super easy, even for a fresher like you, to start coding. Let's start with an integer. Picture the number 12,321. Do you see the magical symmetry in it? That's precisely what we'll be focusing on. We'll create our very own Python function. Let's call it is_palindrome_integer. Just to give you the general idea, here's how the code blocks flow. We first convert the number into a string because it makes sense and is easier. Then we compare the string with its reverse, and if they are the same, voila, we have a palindrome. That's something, isn't it? Let's take a deeper dive. We start our function by defining it using Python's definite keyword and setting the function name as is_palindrome_integer. Inside the parentheses, we specify int because we are only looking at integers. We end in -int because we will be returning an integer result 0 or 1. Inside, we first convert the integer into a string using str, perform a direct string comparison with its reverse and return the result, our palindrome checker at work. But what about cases where the result could be either 0 or 1, correct? In Python, true and false can be translated to 1 and 0 respectively. So, it's just converting our palindrome checker logic into something that matches our desired return values. This method makes things simpler and keeps our code neat and readable. Let's say the input is 12,321. When we run our is_palindrome_integer function with this input, it converts 12,321 to string, reverses it, and then does a comparison. The reversed string 12,321 matches 12,321, implying our number is indeed a palindrome. It returns 1, indicating true, as expected. Let's switch gears a bit. How about strings, like names? The core logic remains the same, convert to string and check with the reverse. Although we won't get integer output, the palindrome logic holds strong. We'll write another Python function called is_palindrome_string and let's follow the same principle for it. Imagine we have the string madam. Converting it to a string would still retain its form madam. When reversed and compared to the original string, given the matching result, we'd get the palindrome designation. Neat, isn't it? Now we have two Python functions that check if an integer or string input is a palindrome. We could easily expand these to accept lists of strings or a single string as input and further refine our functions for robust applications. Wrapping up our palindrome exploration, let's discuss error handling. We've assumed that the inputs are always the right type, integer for integer checks and string for string checks. But what if a user feeds something unexpected, like a list or a float? In real coding scenarios, it's vital to provide appropriate checks and user feedback. We could enhance our code by validating input types and gracefully managing inappropriate inputs. Python's try-except blocks would come in handy here, ensuring our palindrome checker gracefully handles erroneous inputs, preventing crashing, and guiding the users while they learn. So, here's the magic behind identifying palindrome-like patterns. Even if it's in a seemingly unrelated area, a simple yet elegant Python function. But hey, remember, the world of coding, like solving puzzles, always evolves, and there are often hidden treasures beneath the seemingly mundane. The exploration never ends. Hey, I'll take you to a website where you can learn and create even more engaging Python projects. Visit neeraj.qzz.io and subscribe to TechLab for a treasure trove of Python tutorials that are as enjoyable as they are comprehensive. Keep exploring and making your coding journey extraordinary, one palindrome at a time.